everyone. Today we're here with Feynman, one of the collaborators on a thing called BachBot. When I saw this, I was really blown away with how they were trying to take this idea of Bach and put it into AI. I had to literally learn more. Feynman, how are you doing?
I'm good. How are you today?
I'm doing all right. I'm doing all right. I'm in my in-laws' basement, so it's a whole little guest room thing going on, which is interesting. But tell me a little bit. I'd love to learn more about BachBot and how you got started on that research.
Yeah, sure. So I was at the University of Cambridge in the UK working on my master's thesis. And one of the research projects which was proposed for the master's thesis by Microsoft Research Cambridge was to generate music that sounded stylistically indistinguishable from actual Bach. And so that was where the kind of origins of BachBots come from.
Cool. And so were you working on something else before that that kind of was setting you up for that? Or like what were you actually doing when that challenge was brought up?
I was in a course called Machine Learning, Speech and Language Technology. So yeah, there was a lot of course material about machine learning and specifically applications of machine learning to sequences. So whether it's sequences of phones, sequences of words, or in this case, sequences of notes.
Cool. And so was this part of like are you into classical music? And so was this hitting on an interest that you were already into?
Uh, no, actually, I have very limited classical music background. What really inspired me about this project was doing machine learning in a way that the average person could just look at it and understand.
Yeah, I do think I've had a couple different guests on here, and it's been really interesting, the applications of ones that are very consumable through your website, and it's bachbot.com, and I'll put the link in the description. But it's really interesting, the ones that are really consumable, at least for friends and family, I'm able to kind of pull up your website and say, hey, this is an example of kind of what some machine learning stuff is going on. And people are like, oh, wow, that I can actually wrap my head around that. I can like, see the value. And of course, to get the question of like, okay, can you replicate Tupac for me? Or can you replicate, some other musician, and so the kind of that conversation goes on. But I think that it's totally true that tangible piece is really interesting, especially for the general people.
Yeah, definitely. No, I mean, the kind of research I like to do is just research where I can show it to other people, and it's not just the research community, but the greater public in general can engage with me and draw inspiration from and give me ideas, inspire my new research directions from.
Yeah, that's awesome. So how would you describe the actual, like what are we actually looking at? And I'm gonna actually screen share my screen and just pull up the website and maybe click. And can you see my screen now?
Yeah.
Okay, so I actually have your site up. And should I play the sample for everyone to kind of hear what this actually sounds like?
Yeah, sure.
What did we hear was kind of sample one?
So sample one is a sample that is a complete original composition by BachBot. So we trained BachBot on all of Bach's chorales, and then we asked it to just compose a piece out of thin air, and that is what it came up with.
Cool. And so what is some of the actual, I think I was reading on the site that you were using long short-term memory network. Like take me through a little bit of what that means as it relates to this project.
Yeah, so we used, the general class of models that we were using was called a recurrent neural network. So this is a type of neural, should I explain neural networks?
Yeah, go for it.
So neural networks are they're originally inspired by biology, but since then have kind of been drawn towards actual just produced high performance than modeling biology correctly. But there are these computational models where you have neurons and they have weights, and these weighted connections produce output signals, which are then repeatedly processed by other neurons to eventually generate probability distributions over notes in my case. And a recurrent one just means the weights are shared across different points in time. So that this makes the model a bit easier to describe. A long short-term memory is just a really special version of a recurrent neural network. And what we use these things for is to produce probability distributions over sequences. So that once we have this distribution, we can sample it and grab sequences that are likely under this distribution of stuff that is what we hope to believe represents compositions which Bach would have generated.
Mm-hmm. So how did you actually take all of his music and kind of put it into a data format that you could manipulate?
So There's a really nice corpus of Bach chorales encoded in music XML. And we used a Python package called Music21, which provides a really nice corpus iterator for us to just grab all of this music data and encode it into a format which was amenable for processing by long short-term memory.
Hmm. So you grab this corpus. It has all these different, songs. And do you know how big that corpus was?
It's about like 370, maybe to 400, something around there, number of chorales.
Okay, cool. And so that's just kind of this kind of sample size of all the different ways that he's played music. And so is this idea of saying, okay, he would typically play this note, and then you would expect to see note X, Y, and Z potentially after that note. Is that kind of the probability distribution you're talking about?
Yeah. The intuitive notion is I've seen the music all the way up until this point in time. What's the probability distribution over the next notes?
Hmm.
And so, if you're close to the end of the song, say you're one note away from the very end, you're very likely to resolve back to like the tonic. And so you would want your probability distribution to be the tonic.
Right, right. I think what I hear you saying is as you move through, so in the beginning of a song, without hearing a first note, there's really a wide open range of things that you could do. And then as you move through the song, that kind of is closing that probability because of the structure of a song. Am I saying
Yeah.
that
I mean,
right?
exactly. Yeah. Once you've composed your first phrase, the second phrase should kind of be stylistically similar to the first phrase.
Hmm.
Um,
And go ahead. Sorry.
there's one little caveat. We actually start almost all of our songs on C or within the C major scale because in the pre-processing we transpose everything to C major A minor.
Oh, interesting. So I always find it interesting, kind of all the other little tidbits. Like when you hear that sample one, is there a certain style that you know that your model is maybe playing that is different to Bach? I know there's a quiz. Are you able to get 100% on the quiz?
Uh, I am actually not able to get 100%. I'm not the best trained.
Yeah.
Um, there's some music theorists at Cambridge. I gave it to them. They got 100%. There are other music theorists at Cambridge, which I gave it to, and they got 20% or 0%. But on average, we see that people who haven't really studied music, like myself, we perform at around 56, 59%. That's kind of the population average. So that's saying that BachBot is just people perform only 6 to 9% better than complete random guessing on the quiz. But
Mhm.
for experienced musicians, that number rises up to 70, 80%. So for these people, people are performing 20, 30% better than random guessing.
And is there a certain, did you guys discover a certain skill set or identification process that the people who are really skilled at understanding music that they were able to kind of say, this was what triggered it for me?
I hear people say things like, "Oh, counterpoint, oh, parallel fifths." Like, there's apparently some very prescriptive musical rules for chorales, which the model hasn't really fully picked up on.
Hmm.
I don't have enough music theory to really comment on what those
Yeah.
things mean.
Do you think, like, so would there be an opportunity, for example, to expand the corpus with a bunch of different classical music and maybe start to learn some of these rules, but then specifically train BachBot on his music? Would there be a hybrid model approach that might expand some of that model or those rules that you're talking about?
Yeah, that's a really interesting idea. The idea of like kind of transferring like learnings from other corpi into this particular task. And that's actually very similar to Bach's own compositional process. I mean, a lot of his chorales were inspired by earlier works like Pachelbach chorales, for example. So yeah, I mean, I do think there is opportunity to actually expand from outside of this corpus and then later specialize, but I haven't explored that.
Yeah, yeah, that's really interesting. I try to ask everyone who's kind of doing generative pieces, but who owns the copyright to the music that BachBot produces, in your opinion?
Well, I mean, so Bach's music is like, at least his compositions are public domain now. So the training corpus is not proprietary. Um, all the software I use to build BachBot is open source. I
Yep.
think some of it is actually GNU GPL v3. So that means that all derivative works have to also be open source. I don't know. And, I don't really care. I think whoever wants it, I would actually kind of, I mean, I'm not a lawyer, but I would be fine if it was public domain.
Let me take a moment to say that this wouldn't be possible without companies like Amazon.com. If you have experience with machine learning and are looking for a new challenge, they have over 100 opportunities available. Be sure to check out the link in the description, and let's get back to the show. I think it's interesting. I follow a couple really great people working in this space on Twitter, and there was a really good debate talking about who should own it and how it should work. And there's some legal opinion that because a human actually didn't output the music part of it, or the, you know, that painting of it, whatever the medium might be, that there's technically not copyright ownership there, which is really interesting when you think about it from yourself and how much time and energy you put into it. If you were trying to commercialize this, would you own the rights to that? It's an interesting discussion that I think will be really, we'll find out more as it plays out in the courts soon.
Oh, interesting. Are there actually pending court cases for generative stuff?
I can't name any specifically off the top of my head, and I'd have to review the Twitter discussion that I was reading to make sure I got the context right on that. I don't know if it was someone saying, like, hey, I talked to a lawyer about this, and this was kind of the advice I got, or if there was actual court cases. But interesting conversation nonetheless, and I think it's relevant to us. And you talk about that open source piece of it, and it is amazing how much you're able to build off of using the public domain music, and then you're using, you know, you mentioned like Python, things like that, to build off of it. And we're kind of all merging this stuff together, that the commercial applications become interesting when it comes to licensing and whatnot too.
Certainly, yeah.
Cool. So what was the most challenging part for you while working on this project?
I think the most challenging part was at the beginning of the project, we didn't have this subjective evaluation, take the quiz figured out. And so one of the questions that we had to answer very early on was how good are we doing? How can we evaluate, you know, the performance or the goodness of our current work? Because if we don't have that metric, we can't really say, oh, this modification I made is improving what we're doing. One common proxy, which is often used in language research, is a perplexity, or log likelihood or likelihood. So it's how likely is the real Bach pieces under the model that I generate. There's a lot of flaws with this type of modeling. In particular, if your model just memorizes what Bach did and only repeats what Bach did, then it would do really well on training complexity or training perplexity. And so, yeah, balancing off between generating novel compositions while also retaining the stylistic qualities of Bach, we couldn't really come up with a good metric. The best one we came up with was, let's just put it on the internet and see how people can differentiate.
I like that. Yeah, it makes me wonder, and kind of learning more about these adversarial networks by battling against each other. It makes me wonder if you could take the quiz and get the feedback, and it's like, as people start guessing right, does it manipulate other aspects, and having those two kind of systems going against each other to create this like really, really indistinguishable quiz would be an interesting approach.
Certainly, yeah. I mean, I actually looked at, so we have a finite number of questions that we give out on the website. And I actually found that, you know, there were some questions where people were doing really, really good, and other questions which were virtually indistinguishable. So I do think that, like, you know, if we were to continue this work, utilizing that knowledge of, okay, what's actually going on in these pieces where almost everyone can tell the difference. And yeah, I mean, like you said, it is kind of adversarial, although we're not jointly training the discriminator and the generator. But I mean, we are learning from our mistakes.
Yeah, that's cool. What do you see as potential applications for the kind of the underlying research that you worked on?
Well, Google Magenta has actually, they recently released a polyphonic model, which is based on BachBot. Google Magenta is, I mean, I talked with Doug, and my understanding is their direction is they're kind of building stuff that you could for live performance and for composition. So for example, you could like play some music or play a lead line, and then you could use the polyphonic model, BachBot, or whatever Magenta implements to construct, you know, the alto, tenor, bass lines for your piece. I think that's really exciting because now it's not just research. Now it's actually you're harmonizing with machines live.
Mm-hmm. Yeah, it makes me think of, and I think a lot of this creative AI stuff that I'm really interested in. You're kind of, I feel like you're able to reduce certain skill sets to be able to make really great things, right? If I'm a really great drummer and I want to become a drummer, be able to produce interesting, high quality stuff, maybe these types of tools enable me to succeed and kind of help me along the way, as opposed to me having to round out my skill set, which I think is an awesome approach for humanity. And hopefully that's all of the AI type contributions, right? Is these supplemental contributions. So I think it's awesome.
Certainly, yeah. I mean, there's another Cambridge company, or I guess they're London based now. They also do like generative music. They're called a juke deck, and they're much more focused on the commercial applications of this. So they have some generative music stuff which they sell as royalty-free music. Just pay this one-time licensing cost.
Oh, and maybe use that as like a background check or some sort of like stock image type stock music concept.
Exactly. Yeah, like for intros to podcasts, for example.
Right, right. Which, by the way, so this is my 5th episode now, and I emailed you before the first one, and I asked you if I could use a little bit of it, and so that is the kind of the intro sound bit. It's like 4 seconds of one of the samples, but thank you very much for letting me do that, and I think it's exciting to be able to interweave that into a real application, like you said, podcast intro music. Perfect.
No, my pleasure. I mean, I'm very excited you're using it.
Yeah, cool. So what are you up to next? What are you excited about?
Well, I just got back from NIPS 2 weeks ago, where I was working on a paper about deep distributed decision trees. We called it Yggdrasil after the Norse tree of life. I'm in a PhD program right now, so I'm very much focused on publishing and doing research.
Yeah, and how long are you still in school?
I'm in this PhD program for 5 years.
Wow. So how long have you been in it thus far?
Oh man, I did 3 years of undergrad at Amherst, and then 2 more years of undergrad to get my engineering degree at Dartmouth, and I did my master's last year at Cambridge. So cool. I've been in it 6 years and got 5 years left.
Wow. That is a lot of schooling, a lot of learning. But it's really awesome to see your work kind of out there. I mean, sometimes when I talk to PhD friends, and they're often not in the engineering world, like software development area, it's always interesting for them to for me to see their work. It's really hard for me to consume, and it's exciting for me to be able to already interact with your work while you're still kind of in the thick of things. So that's awesome. I'm assuming it's too soon to even ask kind of what you're even looking for on the outside of that 5 years, but is there anything that the audience that might be listening could be helpful in?
I mean, yeah, no, I have no idea what I'm going to be doing 5 years later.
Yeah.
I mean, I'm currently also working part-time as an engineering manager at Gigster, this company here.
Cool.
And we are recruiting software engineers. So
cool. Well, there you go. And what does
good software engineers listening?
Yeah. What does Gigster do?
It's a freelance software engineering company, or it does software engineering consulting. So we provide like a fixed cost estimate of a software project up front, and then we source network developers to work on this project and deliver, and pay from the client is the payments are done per deliverable milestone.
Oh, cool. So you might say, hey, I need to get this web project done. There's going to be 3 milestones involved, and then you guys are going to kind of figure out how to bring a deliverable that's scoped correctly for milestone 1, which I release to you in milestone 2. Is that kind of how that works?
If you came in with your own milestones, we would be more than happy. Usually clients come in and they're just like, hey, I want a website, I want a mobile app.
Right.
And we have to write the milestones.
Right. That must be the product manager in me, which is my day job. And saying like, all right, so the defined deliverables are around these 3 milestones, and I scope it out so that there are no confusions as we're developing product across the company. So, but no, that sounds great. Yeah, and so if anyone's listening and you're kind of looking to join the team, I'll put a link in the description to kind of get more information. But that's cool. Anything else? Kind of maybe 30 seconds, 60 seconds. Anything you'd like to say to the world? I guess it's kind of soapbox mode.
Yeah, BachBot's open source. GitHub.com/Feynman Liang/BachBot. Probably link it in the description if you want. I'd love if you guys contributed, checked out the code, ran your own models. We recently ran this workshop at Cornell, and we had one of our participants train the model on a Beethoven piano music, which the model didn't do too well on because Beethoven's got 10 fingers, Bach's got 4 voices.
Right.
But, I'm curious to see what anyone else can come up with from this project.
Yeah, I suppose you could kind of just keep going. Could you apply it to something like guitar chords or something like that? Does it really matter the like musical instrument as long as you're inputting it into the model correctly?
Guitar would actually be a really good application because the polyphony, the number of simultaneous voices, is limited to 6 rather than 10.
So like a Jimi Hendrix, I'm trying to figure out what Jimi Hendrix would be up to would be
Oh,
pretty
Jimi Hendrix would be great. Yeah,
yeah.
because I mean, he's usually like he plays a lot of like one note or monophonic riffs.
Interesting. Interesting. Well, so that's another, that'd be, yeah, I would love to see that. So if anyone is listening that might be interested in applying that to Jimi Hendrix, we'd both love to see that. We'd probably need to have you on the show as well and learn more about that. But that's really awesome. Well, cool. I appreciate you joining on the show. Thank you. Have a good holiday. And thank you for contributing BachBot to society. We really appreciate it.
You too. Take care, Chad.
All right, take care.